What is the relationship between triangle XYZ and X prime, Y prime, Z prime, and Y? So we can say that line segment XY is congruent to line segment X prime, Y prime. We can also conclude that XZ is congruent to XZ. And we can also say that YZ is congruent to Y prime Z. They must be congruent because rigid transformations, such as reflections, do not alter the shape or the size of any object. Letter C says, read the math notes box for this lesson, then make all the statements you can about the corresponding parts of these two triangles. So after you read that math notes box, you then can conclude that line segment XY is in fact congruent to line segment XY prime. XZ is congruent to XZ. YZ is congruent to Y prime Z. Angle Y is congruent to angle Y prime. Angle YXZ would be congruent to angle Y prime XZ, and angle YZX is also congruent to angle Y prime ZX. 7-29 says, remember that the midpoint of a line segment is the point that divides the segment into two segments of equal length. On the graph paper below, I plotted the following points. I plotted point P at the ordered pair 0, 3. I plotted point Q at the ordered pair 0, 11. I then figured out where the midpoint was of these two. So half of 8 is where M is located, which is at the ordered pair 0, 7. Examine the diagram below for 730. It says find two equivalent expressions that represent the area of the inner square. So when we look at the inner square, to find the area, we take the length times the width. So if we take C times C, we know that that is equal to C squared. When we're looking at our individual triangles, we can see that this is, in fact, a right triangle. Both legs are A, B, and the hypotenuse is C. We know that A squared plus B squared is equal to C squared, so we can say that A squared plus B squared also represents the area of our inner square. (7-31) For each pair of triangles below, decide whether the triangles are similar and or congruent. Justify each conclusion. So looking at these two triangles, the very first thing I want to do is set up some proportions to see if they are in fact equal. If I put the littlest side over the littlest side, I get 0.6 repeating. If I put the medium side over the medium side, I also get 0.6 repeating. And if I put the largest side over the largest side, I also get 0.6 repeating, so we can say that these two triangles are similar by the side-side-side similarity theorem. When we look at letter B, when we have two parallel lines, we know that the corresponding angles are congruent. So we can say that this is similar by the angle-angle similarity theorem. When we look at letter C, and we notice that they both have a right angle, and the bases are both 6 units, we have not enough information to state that the triangles are congruent or similar, so we will just say not enough info. When we look at letter D, we have an isosceles triangle where the two sides are congruent and the bottom angle is 72 degrees. So we know that the other angle should be 72 degrees. When we subtract both of those from 180, it tells us that this top angle is 36, which you can see this angle in this triangle is 36. Our bases are also the same. So we can say that these two triangles are congruent, and we can write by the definition of angle-side-angle congruency theorem, or we could even say angle-angle-side congruency. 732, on graph paper, plot and connect the points. A is 1, 1, so if we take this as our origin, 1, 1 is right here. I'm going to label it point A. It says B is 2, 3. C is the ordered pair 5, 3. So you should be going, oops, B I did too high. 2, 3, 5, 3 is C, and 4, 1 is D. And then we can start answering our questions. What is the best name for this quadrilateral ABCD? We would say a parallelogram because it has two sets of parallel sides. So the opposite sides are parallel. Find and compare the measure of angle DAB to the measure of angle BCD. What is their relationship? So we say that those two angles are equal or congruent, So we say that angle A is congruent to angle C by the definition of a parallelogram. Find the equation of the diagonals for AC and BD. Are the diagonals perpendicular? So when I look at this, I want to connect my B and my D is the line we're going to start with. If you extend that, you can in fact see where that crosses your y-intercept. You can also draw slope triangles to see what your slope is, down 1 over 1. So the equation of the line would be y equals negative 1 over 1x, and our y-intercept is at positive 5. When we take a look at connecting A to C, we would actually need to take our graph 1 unit out to get it in a nice space. We can see that it crosses our y-intercept at positive 1/2. And then we can see that if we drew a slope triangle, we would go up 1 over 2. So we rise 1 over 2x for our slope. And we just wrote our equation of our line. When it asks, are the diagonals perpendicular? Well, in order for lines to be perpendicular, they have to have opposite reciprocal slopes. So we are going to say not perpendicular. And remember, you can draw this little symbol to mean that, perpendicular, because the slopes are not opposite reciprocals. Find the point where diagonals AC and BD intersect. So after you draw those dotted lines, you can easily tell where they intersect, and they intersect at the ordered pair 3, 2. In 7-33, we are going to solve the systems of equations below. So when we look at the following system, I am going to solve this system using elimination. And that's where I want to eliminate a variable. So I need to make their signs opposite. So I'm going to multiply one of these equations by -1. So now I have negative y is equal to positive 1/3 x plus 2. I then am going to rewrite my top equation underneath it so that I can easily see to add these two things together. Negative y plus y gives me 0. 1/3 x plus negative 1/3 x gives me nothing here as well. And 2 plus 7 gives me 9. Well, the last time I checked, 0 does not equal 9, so we say there is no solution because it forms a false statement. And when we have no solution, these two lines would be parallel to one another. You can also look at their slopes because these are both written in slope-intercept form and tell that they have the same slope, so that in fact reinforces the fact that they are parallel lines and they will never intersect. When we look at example B, I am also going to use elimination. If you choose to use elimination, you need to make sure that all of the x's, including the x squared, cancel out, or all of the y's cancel out. So I am going to multiply my bottom equation by -1 in order to get my y's to have the opposite sign. I'm going to rewrite my top equation so that I can add these. Negative y plus y gives me a 0. Negative x squared does not combine with anything. 2x and 2x give me a 4x. Negative 3 plus 3 give me a 0. Whenever I am solving a quadratic, I need to either factor, use the quadratic formula, complete the square. This is in fact factorable. I'm going to factor out a negative x, so I'm left with x minus 4. I then can use the zero product property and set negative x equal to 0, which when you divide by a -1, you get 0 is equal to x. I'm going to set x minus 4 equal to 0. Inverse operations, we get x is equal to 4. Remember, you are solving for where these two things intersect, so this line and this parabola, so you need to plug your x values back in. The top equation looks to be the easiest, so y equals 2 times 0 plus 3 gives me y equals 3. So they are going to intersect at the ordered pair 0, 3. And when we plug in 4, 2 times 4 gives me 8, plus 3 gives me 11. So this line intersects this parabola at the ordered pairs 0, 3 and 4, 11.